Okay, this is a short video to go over the review that we had worked on in class. We didn't quite get all the way through it, so here's a review, especially for anybody who was absent or anybody who wasn't following along in class. Hopefully this will help you out a little bit. So here we go. Our first question is, if a polynomial has zeros of, and we've got 5, -3, and 0, which one of these could be the factorization down here? Okay, well, right away, if you see a 5, remember it's always factors come from x minus solution. So that's the factor, and then x minus -3, we have to have that. And then 0 is a solution, so you can think of it as x minus 0, but x minus 0 is just x. So the three factors that we have to have are these three factors. And so if you look at the answers here, this first one has -4 as a factor, but it has the x right there. That x is a factor of it. Just means that x is multiplied times everybody else in here. Okay, -4 is a factor of the whole thing too. But that -4 does not affect our solution. Only x's give us solutions. So this x as a factor would give us the solution 0. X minus 5 gives us the 5, and x plus 3 the 3, and we're done right there. This one is not the answer because it doesn't have that x. It only gives you two solutions, the 5 and the -3. This one, this 0 right here, right away makes this equation really f of x equals 0. This equation is nonsense, kind of. And D here, this one gives you 0, so that would work, but this factor gives you -5, and we wanted a +5, so clearly our answer is A there. Now remember, we were practicing for the SAT, so we're just filling in and keeping track because that's part of the skills you have to have for the SAT. All right, question number 2, again, if a polynomial has these zeros. So we got x minus 2 is the factor, x plus 3 is the factor, and x minus a half. You can see we've got the x minus 2 and the x plus 3, but this factor x, that just gives you 0 for a solution, so it's not that guy. This x plus 2, that's incorrect right away, so we know it's not this guy. There's an x minus 2, x plus 3, and a 2x minus 1. This one's kind of interesting. We should investigate that one. Clearly, 2 gives you 0. X minus 2 gives you 2. -3 from the x plus 3. And 2x minus 1, if you set it equal to 0 and solve for x, divide by 2, yeah, it gives you that half. There it is. This one gives you the 2, the -3, but this just gives you a 1 for a solution. This half is just a factor of 0.5. It doesn't give you another solution. Question 3. If p of x has those factors, what's the product of its x-intercepts? X-intercepts are the same as the 0, so the solution here, the 0, is 2. X minus 4 gives us 4. X plus 7 gives us -7. And if we multiply them, that's what product means, multiply. That gives us -56. Question 4. Got a polynomial with rational coefficients. It just means the coefficients are nice integers. And some of its zeros are. So some solutions are 3, 4 plus root 3, and 4i. Which of these is also a solution? Well, 0, no. -3, no. Right here, as soon as you see this radical 4 root 3, these things always come in those conjugate pairs, so -4 root 3 has to be a solution. Also, 4i is a solution. That's a square root of -1, so imaginary solutions also come in those pairs. So instead of the -4 root 3, if they had a -4i here, you'd choose that one. Question 5. All right, if a minus b times a plus b equals a squared minus b squared, and we apply it to multiplying these two together, if you look at those two, those are written in a minus b and a plus b form. And you can see the formula right here says the answer is just a squared minus b squared. So let's do that. We'll just calculate a squared minus b squared, and I'm going to slide this over just a little bit. And so our a is the 3, and our b is the 4 root 5. And so a squared minus b squared would look like this. And 3 squared is 9, minus, and you got to square this 4 root 5. And some of the students have been having a hard time squaring 4 root 5. This is the way it works. When you square it, you're squaring the 4 and you're squaring the root 5. And so what's going on here, we can zoom in, is the 4 squared is a 16, and the square root of 5, you square root 5, but then you re-square it. These two things, the square root and the squaring, they just undo each other. I mean, if you want to take root 5 and square it, you get root 25, which is just 5. And so right away, this is just 16 times 5, or if we look right here, this is 4 squared, 16, root 5 squared is 5, so it's 9 minus 80, and that's negative 71. So that's what we get when we apply that formula that they asked us to apply to it, that negative 71. Now you wouldn't get that. That's not the only way to do this. We know how to multiply binomials, so you could just do your distributing of the 3 to both terms, the negative 4 root 5. And if you do all that math correctly and simplify it, you'll get negative root 71 also. Problem number 6. Polynomial p of x is graphed below. So here's p of x on the graph. Here's our x-axis. Here's our y-axis. What can you conclude about the degree of p of x? Well, right away, if you look at this graph here, it shows that it has 2 zeros right there and right there. So this equation, p of x, whatever it is, it has to at least be an x squared equation, because remember, the highest degree tells us, or the highest exponent, the degree, tells us how many solutions we have. But that number of solutions, you have to remember, includes reals and imaginaries. And so while we can see that there are 2 solutions, there could be some imaginary solutions that we can't see. And therefore, we're going to answer that the degree could be 2 or more. Okay? And how do we write 2 or more in math? Well, we're going to choose this one right here. The degree of p is greater than or equal to. The equal to is the 2, and the greater than is the more part. And that's page 1. All right, problem number 7. What do we got here? We got this x cubed equation has negative 1 as one of its roots, one of its solutions. Find the largest value of x for which f of x equals 0. So remember, f of x equals 0 just means take the equation, set it equal to 0. Okay, that's what they're asking when they say f of x equals 0. And they've already told us that one of these roots is negative 1, so negative 1, if you plug it in, makes it equal 0. But they want us to find the other values of x that make this 0, and they want us to pick the biggest one. Well, the easiest way to solve this guy is to use the rational root theorem, if you recall, p over q, where p is the factors of the constant term, q is the factors of the lead coefficient, which is just 1, and therefore plus or minus 1. P over q is either plus or minus 1 or plus or minus 2. And that means the only solutions this polynomial has, at least integer solutions, these rational solutions, is either a positive 1, negative 1, positive 2, or negative 2. Well, that means the only one that we could have out of this list is this 2 right here. So that has to be the biggest solution it could possibly have. It couldn't get up to 4 or 6 or 8 because that's not in our list of possibilities. Now, the other way you can do this is once they tell you that -1 is a solution, you could do synthetic division with this polynomial. It gives you 1x cubed, there's no x squareds. And then when you do your synthetic, you already know you're going to get 0 for a remainder, so it makes it pretty easy. But what it does is gives you the other factors. Okay, that's the other factor of this polynomial up here. And that factor can be broken down, breaking it down using r's and s's. Have to multiply to 2 and add up to -1. And you can see if you did the synthetic, got that, and then factored it, the other solutions of this cubic equation are -1 and 2. And so the biggest solution, the biggest x that makes it 0, is 2. Problem 8. Which polynomial below has these factors? Now, depending which class you're in, you may or may not have had to do that. For some of the classes, I think after third hour, or maybe in third hour, we took this number 8 out and replaced it with a second problem at the very bottom of this page. So if you did do number 8, here's how you do it, because it's still a solvable problem. It just takes a little bit too long for what we're trying to accomplish. Okay, so let's quickly just try and solve it here. We can make this thing a little bit bigger. So here's our factors that make up this polynomial p of x, and if we want to find out what the polynomial is, all we have to do is remultiply it. So we've got to multiply x minus 1 times x minus 1 times x plus 4. Okay. Now, when we multiply these things, it will give us a polynomial that has those factors and the solutions, but it may not necessarily go through that point. So we're going to throw in a little factor here at the front of it. And we'll multiply this out to figure out what this polynomial is. I'm just going to bring that a down for right now. So if you're multiplying these, multiply those together first. Let's see here, that's x squared. It'll come out to -2x plus 1. Then multiply or distribute the x squared, giving you x cubed plus 4x squared. Distribute the -2x, giving you -2x squared minus 8x. And distribute the 1, giving us an x, 1x, plus 4. So a times x cubed plus 2x squared minus 7x plus 4. So there's what p of x is. We just don't know what this a value is. In other words, right now, if I were to stick in 2 just into this equation, it's not going to give me an 18 out. But because I know it's not going to, I can actually then use the fact that I'm trying to find a to actually find it. So if I put this 2, p of 2 is 18, in for x, it looks like this. Once I plug that 2 in, I know it's going to give me an 18 out. And because of this, I can solve and find out what the a is. So we got a, and then we'll just start to simplify this. 2 cubed is 8. 2 squared is 4, but then 4 times 2 is another 8. Minus 14 plus 4. So 18 equals a times, this is 16 minus 14 is 2. And 2 plus 4 is 6. So it looks to me like my a is equal to a 3. This is why this problem takes a while. So we got p of x equals, we got our a value now. I should put an x in there. P of x is equal to, my a is now 3 times, and this one we had at the very beginning that has the 3 factors in it. Now you can see none of these answers have a 3 sitting out in front of the parentheses like that. But if you distribute this 3, you get 3x cubed. You get 6x squared. You get the negative 21x. And you get the 12. 3 times 4. And this polynomial right here will go through 218, and it certainly has those 3 factors in it. Again, pretty long problem to have on a short quiz like this, or a short test like this. Let's take a look at number 9 here. 9 gets a little bit quicker and more appropriate for one like this. Describe the translation of f of x minus 4 plus 6. So remember, this shifts it left and right inside here. And if x is equal to 4, it would zero this out, make it equal to 0. And so that's going to shift it right by 4. And then out here, that's your k value. It's just up by 6. So right 4 and up 6 right there, B. 10's pretty much the same thing, except this one's going negative 2 makes it 0, so it's left 2, and it's up 4. But the real question is, what transformation does the negative 3 cause out in front? Well, if you think about that negative 3, and whatever comes out of your function f of x plus 2, that negative 3 is going to take the answers and it's going to, A, make them all negative, so that causes your graph to flip upside down. And then this 3 is going to make it stretch like that. So we know it's going to do a stretch, and it's going to reflect over the x-axis. Okay? Anytime we have a number out in front of your function like that, whether it's positive or negative, the positive negative just controls whether it opens up or opens down. Okay, flips it up side down over the x-axis. But the number in front of it is what stretches it vertically. So a 3 is a vertical stretch, whereas like a 1/3 would be a vertical shrink. We've had those things before. Just a reminder. And then finally 10 on the graph of f of x, what x values is the function less than 0? So here's your x-axis and your y-axis, and here's the y values, okay? So when your x is over on this side, your y values are up here. Here at this x, it looks like right at negative 3, your y value is 0. Then after the negative 3, you start to increase, so you get positive y values. Now these are negative y's. Okay, so that's what our graph shows us. And so they want to know, where are the y values less than, lower than 0? That means down here. That's where below 0 is. That's where negative y values are. And if you look at the graph close, this is right here at negative 1. And this is at positive 1. So in this region, when x is in between those two numbers, we get out negative y values. And then again over here, after we get through this positive region, we increase, we decrease. Eventually we decrease so far we're down here past into the negatives. This is at positive 2, I believe. This is 1, 2, 1, 2, yep. And so on the right side, down here, that's when x is greater than the 2. So we're just looking for the one that says that, and you can see it's right there. All right, the last page here, we got 2 conditions. It says, hey, find out t if t is greater than 0, and it satisfies that equation. So all you gotta do is solve this equation. You can see it's quadratic. There's 2 ways to solve it. Here's way 1. Isolate the t squared, square root both sides, and t equals plus or minus 2. Okay, it says, hey, I also have t has to be bigger than 0. Well, negative 2 is not bigger than 0, therefore t has to be a positive 2. The other way to solve this is the difference of squares. That's t minus 2, t plus 2. That's how it factors. And so it tells you the same thing. T is either 2 or negative 2. And again, we choose the positive because it's bigger than 0. When you put that into your answer sheet, okay, this is how to go. If I'm answering, hey, 2's the answer, I can put the 2 here. You can put the 2 there, there, or there. It doesn't matter, but what does matter is make sure you color in the circle. It does not check this on your SAT. It checks your circles. Let's look at number 12 here. Function g of x is this. A is a constant and g of 4 is 8. Find what the g of negative 4 is. Well, we did just one like this I said was kind of long. But this one isn't quite as bad, and you'll see why. We know everything in this equation except for that a value. And so let's go ahead and plug in when x is 4. The function has to equal 8. And so we'll just solve this real quick. Subtract 24, subtract 24. Negative 16 equals a times 4 squared is 16. So a is negative 1. So g of x, we now know. G of x is a is negative 1, x squared plus 24. And now we can actually answer the question. What's the g of negative 4? Well, plug in the negative 4. And you can see it's negative 1 times 16 plus 24. Negative 16 plus 24 is 8. And so the answer is g of negative 4 is also 8. Now, if we were clever, though, we would have noticed something. And we would have noticed the following. This function, when you put in this x and square it, x squared is always going to be a positive number. And so when you put in a 4 and you square it, you get a 16, then it gets multiplied by a and you add 24, and out comes an 8. When you plug in a negative 4 and square it, this is also a 16. Multiply by a, add 24. It's going to give you the same number because negative 4 acts the same way as positive 4 in the equation. This is called an even function because that's what happens in even functions. 4s and negative 4s act the same way, and so they always give you out the same answers. Problem 13. Okay, so they tell us I is equal to root negative 1, which you're supposed to know anyway. And they say add these and tell us the real part. Well, when you add the real stuff, 7 minus 5 or plus negative 5. And you add the imaginary, 3i plus 9i is 12i. And so the real part is 2. And so we will, oops, I forgot to answer my 8 for the last one. We just fill in 8. And then for 13, the real part is 2, so we'll fill in 2. 14, what is the y-intercept of f of x? The y-intercept always has an x value of 0. So really, you just have to find the f of 0, and it'll tell you the y-intercept. So let's put a 0 in. This is going to be some easy math, because 0 times anything is 0. And so you can work it all the way out like this, but that's just going to be 0. So the y-intercept is 0. Okay, or 0, 0. But because we're filling in that answer sheet for number 14, and we have to put in a 0, you'll notice column 1 does not accept 0. Okay, that's so if you're entering a decimal, you don't put 0 point. They don't want that. In fact, you can't do that because there's no 0 in the first thing. So to answer 0, you have to put it there and fill in 0. Or you can put it here and here. Just put a 0 in one spot, though. Very last one now. Problem number 15 for the graph f of x. What's the value of the largest local maximum? So the maximum of this thing is infinity because that's where it heads to up here. But in this little region, this hump, there is what we call a local maximum. And then here's what we call a local minimum, because in this region, this is the lowest point. And then in this region, there's a highest point. So this is a maximum or a local maximum, and so is this. What's the value of the largest one? Well, the value is the y, and so the highest value here is 6.02. This is only up to 5. So the highest one is 6.025. So if we go to enter that over here, you'll see 6.25 doesn't fit. And so what you get the choice of doing is either entering 6.02 and just truncating that 5, or if you enter 6.03 and round it because of the 5, either one of those answers will get marked correct on the SAT. So make sure you understand that rule when you're answering. And that's it.